Hello, my name is Fritz, and in this tutorial we are looking at the inverse of a 2 by 2 matrix. It is very important that before you take this lesson you must have done the determinants of a matrix as well as the adjugate of a matrix. But if you have not, there is no problem, we are going to do them here as well. The inverse of a 2 by 2 matrix M is denoted M inverse. M inverse, and it is the quotient of its adjugate and its determinant, that is adjugate divided by determinant. For example, if you have the matrix M equals 2, 3, 4, 7, then the determinant is equal to the product of the leading diagonal minus that of the off diagonal. So it's going to be equal to 2 times 7 minus 3 times 4, giving us 14 minus 12, which equals 2. So the determinant of this matrix is equal to 2 for 2 by 2 matrix. And the next thing we need is the adjugate of the matrix. The adjugate of this matrix is given by, we have to swap the positions of the leading diagonal entries. That is, we swap the positions of 2 and 7. So at 2 we now have 7, and at 7 we now have 2. And we change the signs in front of the off diagonal entries. So in this case, plus 4 now becomes minus 4, and 3 becomes minus 3. That gives us the adjugate of this matrix. And finally, to obtain the inverse, we have to divide this adjugate by the determinant. So the inverse is given by 1 over determinant times the adjugate. So we have 1 over the determinant, which is 2, times the adjoint or adjugate of the matrix, which is 7 minus 3 minus 4, 2. And that gives us the determinant as well as the adjugate, therefore giving us the inverse of the matrix. So to have the inverse of a 2 by 2 matrix, you need 1, the determinant, 2, the adjugate, and then we can now look for the inverse. If the determinant is equal to 0, remember from the previous lesson, then the matrix has no inverse. That's your conclusion, and you will not need to look for the adjugate and any other thing. Okay, in general, for any 2 by 2 matrix, the inverse denoted M inverse is given by M inverse equals 1 over det M times H M. So for any 2 by 2 matrix, this is how the determinant is obtained, and even for higher order square matrices. But we will look at higher order matrices like 3 by 3 in next or upcoming lessons. If the matrix M is given by A, B, C, D, then the inverse is given by M inverse equals 1 over the determinant of M, absolute M, times the adjugate of M, which is dA minus B minus C, as we explained earlier. Let us take some examples. Find the inverse of the following matrices. You have 0 minus 1, 5 minus 2. So the determinant of this matrix is 0 times minus 2 minus 5 times minus 1, giving us 0 plus 5, which is equal to 5. The next thing we need for the matrix is the adjugate of n. And the adjugate is given by, instead of 0, we now have minus 2. At the position of minus 2, we now have 0. And then we change the signs in front of the off diagonal entries. So plus 5 becomes minus 5, and minus 1 becomes plus 1. Finally, the inverse is given by 1 over the determinant times the adjugate of the matrix. You can simplify further to have minus 1, that is 1 over 5 times minus 2, giving us minus 2 on 5. 1 over 5 times minus 5 giving us minus 1, and 1/5 times 1 giving us 1/5, and 1/5 times 0 giving us 0. They can equally leave it at that other stage. Second example, we have minus 4, 1, minus 7, 2. First of all, we need the determinant of M, which is given by minus 4 times 2 minus 1 times minus 7. That gives us minus 8 plus 7, which is equal to minus 1. The adjugate of the matrix will be given by 2 minus 4, swapping the positions. Now we change the signs. Minus 7 becomes plus 7, and plus 1 becomes minus 1. And the matrix inverse, M inverse, equals 1 over the determinants, 1 over minus 1, times the adjugate that we have obtained. And when you simplify further, we are going to have minus 2, 1, minus 7, 4, when you multiply all through by minus 1. Well, thank you so much, guys, and stay tuned. There are many other videos we should have on Adjugate, inverses, multiplication, and so on, functions, quadratics, 3 by 3 matrices, and so on. Stay tuned. Bye bye.